today we're going to look at the generation of bond graph models for hydraulic systems. You see, we have an example of this tanks and some valves on the screen, and we're going to see how we generate a model for this, as well as the steps that we need to do that. So what we have is a situation where we have the system in here. The first step was to recognize the elements, right? One is you need to see the elements in the system. Okay, so what do we have in here? So you take a look in here, you have this is a C element, which is the tank in here. This is the inertia and the resistance here, and we have a R element, which is this valve, and in here we're gonna have a pressure here, a source of flow in here. This is another C. This is like this, yeah. So that's the first thing we gotta do. This is of course the source of flow, yeah, on in here. So what happened is the first is to recognize the elements in the system. What is the second step? Second step has to do with the one junctions. So we're gonna say use a one junction to represent the distinct flows. So we're gonna do it right here. You have this in here. This is flow 1. We can say this is flow 2 in here, and this is flow 3 in here. Okay, so we can put this is the distinct flows in there. So what are we going to do? Step number 3. Step number 3, we're going to say attach the elements that see those flows. So I'm going to do a step number 3. Okay, so what elements do we want to attach? The next thing we do is to attach the in here. This would be this, of course, we have the R element in here. This is the atmospheric pressure here if it is opened like this, yeah. And if you leave it like this is the atmospheric pressure with pressure equals to 0, then we're gonna say, okay, this is the source of effort in here with where P is equal to 0. And then in here you're gonna have the inertia and the resistance of this pipe. And then in here you're gonna have again another source of flow. So that would be step number 3. Step number 4 would be use the zero junctions. And number 4, use zero junctions to represent the differences. Okay. So what are we going to do? We'll go in here, view, actually draw. Let's get a different color pen here. So you see, in between these two, you're going to have a 0 over here that indicates that the 0 over here indicates this minus this is what goes into the C element. Okay. And in here you are going to have the other element, this C, which would be the tank. Maybe. And the difference in here between this flow and this one is going to be the difference between those two. Hold on for a second. Yeah. So the difference here is this minus this will produce, this would be attached to the C element in here. So that's this other tank. The C is this tank. That's that. Yeah. So at this point, we could actually enter this into the QMG software. So use zero junctions to represent the distinct flows. And then I would say 5, attach the elements that see those differences. See here. So that's what we just did. This is the difference. This minus this is this one. And we attach the one that see the difference. This minus this is this. Okay, there you go. And then finally, what do we say? Number 6. We will say complete the causal marks and power flow. I would say not complete, but revise, huh? Because in here, the way it is, you could go into CAMG and actually enter this bone graft model as it is, because the CAMG software would actually do the numbering and everything for you. But we are going to stop now in the creation of this bone graft model.